Today we are going to be finding area once again, but this time we're going to be finding it with what we are going to call irregular shapes. Now, an irregular shape can be a shape that maybe you don't have a specific name for, like something really odd looking, but it can also be a shape that we can recognize, but that we don't necessarily have a method for finding area for. So we're going to get started with the following shape. I'm going to start with a shape that's on a grid, and when I look at this shape, I count up the sides and I notice there's 5 shapes to Kara's garden that we see here. And I know a 5-sided shape is a pentagon, which isn't necessarily an irregular shape, but it's not a shape that I know necessarily how to find the area of. So there's several steps to finding the area of an irregular shape. Step 1 is to split your irregular shape into irregular shapes that you can sort of work with a little bit better. Now, when I use this word split, I'm going to really explain that what you're really doing is you're decomposing, because I want to use my good math vocabulary. So we're going to decompose this. Now, when I look at this shape, I see a variety of things, but what sticks out to me is in the center here, I really have a quadrilateral, and it looks like it's a square. And that's leaving me with 2 other shapes. It's leaving me with a triangle and another triangle. And I like these shapes because I know how to find area of these shapes. So step 2. Step 2 for me is I usually number the shapes. Like I'm going to call this shape 1, this shape 2, and this shape 3. What that's going to allow me to do is really organize my work so that whoever's looking at it can follow it better. And then I will follow that organized work by doing the following. I'm going to find the area of each shape individually. So watch what I'm going to do. And I'm going to organize my work down here. So I'm going to have my work for shape 1, my work for shape 2, and my work for shape 3. Okay? Now shape 1 is a square. Now I could definitely use a formula, but honestly, because it's on a grid, I don't even know if I need one. And I'm just finding out that there's 4 squares in a row, and then there's 4 rows. So therefore, I'm just going to do 4 times 4, and I'm going to get 16 as my answer. Now, because I'm not really doing a formula, to the person looking at it, they might be like, well, how did you get that? So I might just let people know that I counted, just so that they know where that 16 came from. Next, I'm going to go to shape 2, and I'm noticing that that's a triangle. This one's going to be more difficult to count the squares inside because of the slants. So because of that, I'm going to use the formula that we came up with, and I'm going to use A equals 1/2 BH. And because shape 3 also has a triangle, I'm just going to rewrite my formula over there to remind myself that I can use that same one. So I come to shape 2 and I'm looking at it. Now the base is usually what it sits on, so I'm noticing that the base is 4, and I'm noticing that the height is 2. Now remember, when you're doing this, you can either do 4 times 2 is 8 and half that answer, or you can half one of your factors, either half the 4 or half the 2, but you can't half both. I'm just going to stick to doing half of 8, and I know that half of 8 is 4, so that's what the area of that triangle is. And then I'm going to move over to triangle number 3, or shape number 3, using the same formula. Now for this base, again, I would probably turn my paper so that I could see something that it's sitting on, and I'm noticing that the best place it's sitting on right now, and I'm going to highlight this in red, is this side. And I'm noticing it's a 1, 2, 3, 4, ooh, and it's also a by 2. So now that I know that, I'm just going to finish it out, but honestly I could have just multiplied my shape 2 by 2, but I do find out that the area is half of 8, and half of 8 is 4. Okay, so now I have 3 different areas. I have one that's 16, I have the first triangle as being 4, and I also have the second triangle as being 4. So my last step is to take those answers and to add or subtract them. Now, different situations are going to make you add and some will make you subtract. In this case, because by putting these shapes together or composing them, that's how I get my irregular shape, which is my pentagon. So I'm going to take my numbers and I'm going to add the 16 plus 4 plus 4, which is going to give me 24 units squared total for this one. There are some situations where you might have to subtract, and we might look at that in a moment. First, I'm going to look at a different shape, and this shape is a trapezoid that you're seeing, and it already has the dimensions on it, which is really nice. And again, you might be saying, well, I already know what a trapezoid is, and that's true, we do, but it's going to be considered an irregular shape for this purpose for finding area because we don't have a formula for that. a formula does exist, but we are not there yet. So even if you're able to find it or somebody tells you what it is, we're not going to use that in 6th grade. We're really going to talk about this idea of decomposing. That being said, when I look at that trapezoid, there's actually several ways that you could split this up. And I'm just going to show you a couple ways, and then I'm going to choose the one that I want to do. One way that many people do is they immediately see that they could split this like this, so that they have a rectangle and 2 triangles that to me look equilateral, or not equilateral, but congruent. So that's one way. That's going to make you have to do work for 3 different shapes, so that's up to you. The other way you could do it is to go right across the diagonal, and if you do that, you're left with 2 triangles, and you would only have to find the area of 2 shapes and then add them together. So it's really a decision that you have to make, and it's up to you. The only thing I am going to say about this, and I think I'm going to go back to the first ways, I'm going to go with this way because this is what many 6th graders do, is that there's something missing. And the something that's missing, I'm wondering if you can guess it, is, well, you know what, I'm not going to tell you yet. Let's see if it comes up. So I've already split my shape into regular shapes. I've got a rectangle and I have 2 triangles. Now I'm going to go ahead and I'm going to number my shapes. Now watch what I'm going to do. I'm going to label this number 1. But when I label this 2, I'm going to label this one 2 as well, because I'm noticing that they look like they're congruent and they look like they have the same dimensions. So because of that, I don't really need to do work for 2 different shapes. I just need to do it for 1 and then multiply by 2. So I'm going to organize my work down here with shape 1 and shape 2. And sometimes next to shape 2, I actually write times 2 to remind myself I have 2 of them. Now, when I look at my rectangle, I'm going to think of the formula A equals LW. It's not on a grid this time. I can't rely on counting, so I have to actually think about what I know. Now, you've got to be careful because it's LW. So remember, L is really this. And I probably should use a different color. It's what I'm showing you in green. That's your L. And so even though I see this number 26, it's not 26. 26 is the whole shebang down here. So because of this, I'm going to even remind myself that if I go up here, where you see my green again, that the L is really 16. Now when I get to the width, this is where I say, ooh, I don't think I have enough information. I know that the slants over here are 13, but the slant is not the same as the height. Remember, it's like if we were rolling down a hill, it would take longer than if we went straight up. So because of that, I'm just realizing that I need to add another dimension. So I'm going to tell you that this, the height is, and I'm making this up, I'm not saying this would be accurate, but I'm just going to say it's 10. Okay, 10 meters. So now I can go back into my formula and I can do 16 times 10. My area of my rectangle is therefore 160 meters squared. When I get over here to my triangles, again, there's no grid, so I really have to use a formula. In this case, A equals half BH. And I'm going to look at this, and again, I'm thinking of the base. Now, the base over here is only part of this big base of 26. So basically what I need to do is say, well, 26 minus the base of the rectangle is 6, which is 16, gives me 10 meters. And because I have 2 bases to each triangle, that means that they're each going to have to be 5. And the height, again, is not the 13. Be careful, that's the slant. The height is that 10 again. Now what you're going to notice is, and some of you might have thought we could have done this differently, is I get half of 50, which is 25. But because we have 2 of those triangles, we end up getting 50 again. So what some of you might recognize is that if we put those 2 triangles together, we would have had a rectangle, and we could have just used our A equals LW formula again. Now because I'm putting these all together to form the shape, which is the trapezoid, I can just add my 160 and my 50, and I find out that it is 210 meters squared total in area. All right, I'm going to take one last example, and what you're going to see here is looks like it's a square, which is a 10 by 10 square, but inside of it is a triangle, a white triangle. Our job is going to be to find the area of this shaded portion, all this gray that you see here that I've just shaded in green, okay? That's what we want to find. Now, when you look at that gray, it is an irregular shape. I mean, it almost looks like 2 triangles, but there's that little gap in the middle there, which does not make it 2 triangles. So because of this, our steps have to be somewhat similar, but there's going to be a little catch on it. So again, what you want to do is you want to see what you have. Now I'm noticing 2 shapes that really stick out to me. I'm noticing the whole square, And then I'm noticing the triangle. Oops, let me change colors here. I'm noticing the triangle inside of that square. So because of that, instead of numbering it this time, I'm just going to say that I'm going to deal with my square and I'm going to deal with my triangle. Okay? So I'm going to deal with my square first. Now, my square, well, we'll talk about it in the end. So I'm going to take my square and I look at it and I'm like, ooh, I can use A equals LW. Lucky for me, it's a 10 by 10. It's a nice, easy calculation. And I find out that that square is a total of 100 centimeters squared in terms of area. When I get to the triangle, again, I know that my formula is 1/2 BH. And I know that the base is 10 because it's one side here of the square. In terms of the height, they did give me another dimension that's over here, which is this 8 centimeters, which is going up the center. So I get my times 8. So now I have half of 80, and half of 80 is 40 centimeters squared. Now, according to what we've done before, we've often added these two numbers. But what I want you to realize, if we were to add them, it would be the same as taking a square and then maybe adding a triangle somewhere on it to maybe look like a house. And we don't want to do that. We want to find the shaded. And we don't have a whole square in the shaded. So what this really becomes is a subtraction problem. So I have to take the 40 away from the 100, telling me that if I take the triangle out of that square, I'm left with the shaded, and that's 60 centimeters squared in terms of area. So you have 3 different examples. Sometimes you add, sometimes you have to subtract, but just use what you know and pull it together.